Hello students, let's solve a question in JAM 2014, question 16 for physics students, and the topic is elastic properties of solids. So here we go. It says a force of 500 Newton. A force of 500 Newton is applied to a steel wire of cross-sectional area 0.2 meters square. The tensile stress is question. So we have options A to D. So what was the correct answer? To get the correct answer, we have to solve for tensile stress. Now, in order for you to solve for tensile stress, you must first of all understand that there is a relationship between stress and strain for every elastic material, and an elastic material is a material that will regain its original shape or size after it has been distorted by an external force. So if an external force acts on a material, it's going to create a stress in that material, and there's going to be a strain. There's also going to be a bit of stress. So now the force is 500 Newton. The force is 500 Newton acting on the material, and the area is 0.2 meters squared. Then we're asked to find the tensile stress. And that is not known. So the first thing is to analyze, which I have just done. I have brought out the quantities which I can find in my question, and that is the analysis. Secondly, I have to get a formula that connects the quantities which I can see. I have to bring a formula that can connect the quantities. I can see force, I can see area, I can see stress. So I have to look for a formula that will connect these three quantities in order for me to solve for the stress. All right, so I don't know if you have come across this in the process of your study, but if you have not, I'm going to tell you now that the formula for stress is the same as the formula for pressure. The formula for stress is the same as the formula for what? For pressure. So if you know the formula for pressure, you are good to go. The formula for pressure is what? Force per unit area. That's the definition of pressure. So we can get out the formula from the definition. Force per unit. Per is over, divided. So force divided by area. That is the formula for pressure. So this becomes the formula for stress. So solving that question, we are going to simply substitute our values. Our force is 500 Newton. Since our force is 500 Newton, so we'll just substitute the values. 500 divided by the area is given to us as what? 0.2 meters squared. So 0.2, and that gives us, so just punch your calculator to get that. 500, so that gives 2500 Newton per meter square. 2500 newtons per meter square. Now, why did I have to work with 0.2? I didn't have to convert it to centimeters or any other unit, because the SI is what? Newton per meter square. And since the SI is Newton per meter square, my force was already in Newton and my area was already in meters square. So there was no need for any conversion. But if my area was given to me as 0.2 centimeters squared, then I would have converted this to meters, and that would have been 0.2 times 10 raised to the power minus 2, and that would have given 0.002 meters squared. So since the unit was given to me in SI, which is meters squared, so there was no need for conversion. So the answer to that question is what? 2500 meters squared. Now let's confirm if we have such an answer in our options. Okay, so in our options we are having 2.5 times 10 raised to the power 4. 2.5 times 10 raised to the power 4 is actually 25000. Yes, and that's 25,000 Newton per meter square. Then look at the second option that is similar, which is option D. This is actually 2.5 times 10 raised to the power 3 is 2500 Newton per meter squared. So this becomes the correct option. So the correct option is option D. Alright, so with this you can solve any question that has to do with stress. Question on elasticity does not only come out from the aspect of extension and force, but you could also have a question on stress, and that's because there is something called Young modulus, and Young modulus is the ratio of tensile stress. Let me just chip this in now so you can know this. So Young's modulus is what? Is the ratio of what? Tensile stress to what? Strain. Tensile stress. So the ratio of tensile stress to strain is what is known as Young modulus, and I want to know that strain does not have a dimension, because we know that stress is force over area, but strain is simply extension over length. And I want to know that whenever we're talking about extension is not just only elongation. Extension does not only talk about elongation, it could also mean a reduction of length, that is compression. When there's compression, because elasticity does not only play out when we have tensile forces, it also plays out when we have compressive force. What do I mean by tensile force? If this is a material and then there is a force trying to pull it out from this end, that we call that force a tensile force, because that force tries to pull the molecules of the materials apart. But if we're having a material and then there is a force pushing it, and let's say this is a wall and then there's a force pushing on this material, then this is a compressive force. So we can see that practically if we're having a spring, and then if you attempt to pull this spring this way, you are exercising using a tensile force. But if you attempt to push back on the spring this way, then that is a compressive force. So in both cases, elasticity plays out. So the ratio of stress to strain is Young modulus, and then extension over length is strain. So if we are to bring that into a general formula, we'll say Young's modulus is equal to stress is force divided by area, all divided by strain, which is extension over length. That means we are simply saying this is equal to force over area divided by extension over length. And for us to convert this division sign to multiplication, we have Young modulus is equal to force over area multiplied by length over extension, because for us to convert the division sign to multiplication, then we have to invert what we have on the right hand side. So length goes up and extension comes down, so eventually that will give us FL over what? AE. So that becomes the general formula for Young's modulus, FL over AE. But I would love you to understand that strain does not have a dimension. Why? Because extension, the unit of extension is what? Meters, because it talks about length, and then the unit of length is also meters. So when we say extension over length, this is simply meters over what? Meters. Meters cancels out meters, and then we have no units. So that is it about Young's modulus and questions on stress and strain in the topic elasticity. So you can try out other questions that looks like this, so you can get them and just play with them.